Good afternoon, everyone. I hope you can hear me. I'm here to present and talk a little bit about Hadoop 3 and give a quick summary in a nutshell. There's a lot of material, so there's some parts I will go fast, some parts I will skip some details that are in the slides. The slides are going to be available as part of the summit afterwards because there's a fair amount of material. A little bit, my co-author is Janping Du. Myself, I've been part of the original Hadoop team at Yahoo since 2007. I was the chief architect for Hadoop Core, and currently I'm at Hortonworks. I was one of the founders over there. So why did the community do Hadoop 3? So there were a number of driving reasons. There is a lot of content in trunk that does not make it into a 2x branch unless somebody thinks it's critical to be in a 2x branch. So there's stuff just waiting to be released. There is a JDK upgrade. Now this doesn't truly require one to declare a 3.0. We could have done it in a 2.x line, but it became convenient, okay? There was a Hadoop command scripts rewrite that is fairly significant. Also, it's incompatible. So something that's incompatible has to go in a major release, but still maybe not the single driving reason. There are some big features that often need stabilizing, things like erasure codes that are in Hdfs. There's some stuff in Yarn. The Yarn stuff is more layered on the top, so one could say you don't really need a stabilizing because only if you use that feature you're going to use it. While in Hdfs, it's right inside the system. Even if you don't use the feature, you're in a system that has been changed fundamentally. There are some features that are really taking advantage of 3.0. They could have been done in a 2.x, for example, Yarn long-running services that just decided to wait till 3.0. There's another one which is an incompatible change. There is ephemeral ports, and if 3.0 wasn't happening, we would have probably not gone forward with this. Okay, so a number of mixed reasons. It was, fair amount of debate and discussion if you follow some of the Hadoop Jiras and email discussions. Okay. The key takeaways about what are the main features. The main features are erasure codes in Hdfs. Yarn has now built-in support for long-running services, which used to be previously available as a slider add-on. There are scheduler enhancements. There is isolation, better isolation for processes, and there's Docker support, which is very, a very popular thing. There's an improved UI. There's a lot of course, trunk content that is going in and moving to a JDK 8 and new dependent libraries. So we released Alpha 1 last September, and then Alpha 2 in January, and current plan is Alpha 3 in Q2 and GA, closer either in Q3 or the end of the year, okay? So I'll kind of cover, some of the basic things that you should know, things like dependency upgrade. Those are not really features and things like that, but that's something you should know. And then I'll talk about some of the high-level features. As I mentioned, there's a fair amount of material hard to kind of do in, half an hour. So let's get started. As I mentioned, we're upgrading to JDK 8. JDK 7 was, by the way, EOL'd in 2015, so this is quite late. Now going forward, Hadoop source code can start taking advantages of things like Lambda expression. It's already starting to happen. For example, the streaming API. There are two other things like security enhancement, performance improvements that you will start seeing. Clearly, no source code is necessarily needed for that, okay? And so here is the kind of the history on the bottom of what was the evolution. So 2.6 was JDK 6, 7, 8. 2.7, 2.8, 2.9 is JDK 7, 8. And as I mentioned, 3.0 is 8 and upper, okay? There are a number of libraries that we are moving to newer libraries for Jersey, Grizzly, Juice, Netty, etc. Protobuf and Netty are under consideration, under discussion right now, okay? So generally when you move to the new libraries, you get benefits of improvements in implementation, security, things like that, okay? The other one is default ports. So Hadoop traditionally has used ephemeral ports. which typically are given to any service application that runs there. So if you had something running before you start a Hadoop service like a data node, name node, or yarn resource manager or something on the node, it could potentially conflict. And so really we've kind of moved towards the range from 1,000 to 10,000. And so here are the list of kind of what are the upgraded port numbers. And so kind of all in the 9.8 range. And the KMS, which is the key management service, will move to 9.600. So this would be an incompatible change with applications that connect into it. Again, remember, we're going through alphas. If a lot of feedback comes back, some of these things could be reversed, because that's kind of one of the purposes of alpha, besides just testing the system. Okay, so now I'll kind of go to some of the core parts of the system. In Hadoop Common, the major change is really the two actually changes. One that I'm not going to talk a lot about is the fact that we had client jars and server jars were together. And so what happened, if you're an application, you're more likely to have conflicts with dependent jars. And so what we have done is two things. We have separated the server-side and client-side jars. So, some of the server-side jars don't even get picked up. And so your chances of a conflict is less. And the second thing is that the dependencies can be shaded. So for example, if you are, if a particular Hadoop client, let's say, depended upon protobuf, then we could, rename it as, shaded protobuf as the package name, so that if you are using a protobuf with a different thing, you would actually not have a conflict, okay? So that's a pretty standard trick. So that's kind of going to happen, and that'll help a little bit in managing, dependencies and conflicts. The next thing I'm going to talk a little bit about is the Hdfs. So we are moving towards supporting 3 name nodes for an HA name node. Previously, we only used to support a maximum of 2 nodes. A number of customers requested this. I don't have any slide on that, but it's a pretty simple feature. It wasn't possible to do that easily in the past. So that is being fixed. And the other major feature in Hdfs that is happening is erasure coding. I'm going to spend some little bit of time on that. Okay, so as you know, the way Hdfs works, it has 3 replicas. First replica is on typically where your client is, and the other 2 replicas are on another rack. And as Hdfs moves blocks around, recovers, etc., it makes sure that blocks are on separate racks. Okay, so the third part of having 2 on the same might get changed and move on all 3 different racks once things start moving. Okay, there is obviously good locality for your writes and even for your reads, so your chances of getting a local client is very high, and that improves your performance for reading something. And there's also a local shortcut that goes and reads straight from the OS file system. Okay, there is very, very, very fast block recovery and node recovery. So in Hdfs, if a whole node, 10 terabyte node fails completely, it can recover that in 30 seconds if you had a 3,000 node cluster, or if you had a 100 to 500 node cluster in half an hour to 3-4 hours. Recall that if you're doing something like a RAID disk recovery, 1 disk, not 10 terabytes, 1 terabyte disk could take 24 hours. Okay, so this is this is only possible because of the fact that Hadoop has replication this way, and this is a feature that a lot of people don't realize. Now, however, 3 replicas means 3x overhead, and an alternate technology, which is erasure code, will have somewhere between 1.4 to 1.6, depending upon what kind of erasure coding you use. So this is a feature that's being added, but as I mentioned, there are some of the advantages of replication, as I mentioned above, and the other one is you also to remember that Hadoop storage is quite cheap. It is 1/10 to 1/20th of the cost of a SAN, so it's like in the order of under 5 cents versus $1. Okay, and for NFS, it's like 5 cents versus 50 cents. Okay, so it is Hadoop storage. If storage cost is your main thing, it is already cheap to start with. Okay, but erasure code is in. It has been beta tested heavily at Yahoo Japan. So Hortonworks has worked very, very closely with Yahoo Japan for beta testing this feature. So what does erasure code do? So what you have is for example, typical thing is to use K data blocks and M parity blocks. So a very common one is Reed Solomon 6.3, which is what I've drawn in the picture up there. So I have 6 blocks which hold the data, and then I have 3 parity blocks. And so what happens is I can tolerate, m failures, the number of parities there are. So in this case, for example, I could tolerate 3 failures. What it does, it saves disk space, and it also saves some I/O bandwidth on the write path, okay? So for example, on the table at the bottom, I kind of show that, failure tolerance in 3 replications is 2, failure tolerance in read Solomon 6.3 is 3, and the storage overhead is 3n times the number of bytes, and 1.5n times the number of bytes, okay? So it's about half the cost of erasure code is half the cost of replication. So what happens is, here I have a set of blocks that have been replicated, and then if you happen to, say, lose a replica, one of the instances here, in this case I've lost the major, it can go and really recover it from the other blocks and the parity. Okay, and this works for whether you lost parity or the blocks. Okay, there are really kind of 2 approaches. One is to use what we call contiguous blocks. It works much better where you lose entire large blocks and you need to have a large file. And so here I'm showing, large file blocks that are being replicated. However, small files do not work well in this picture. Okay, so the other approach is to stripe. Okay, and is to basically stripe across the blocks. This does work for small files, but this does not have locality. Okay, so we have actually decided to go with the striping approach. Okay, in this phase 1.1, which we are releasing in Hadoop 3. So you can have striping for erasure coding, or you can do Hdfs with replication, which is the bottom left-hand corner. In a future phase, we may do the contiguous style blocks for larger files in order to get replication. Not that it doesn't work for larger files, it does work, but in order to get locality. Okay, so that could potentially happen. How do you tell the system I want to use erasure coding? Basically, you create a subzone, you mark on a directory that things underneath need to be erasure coded, and then any file you create underneath are automatically going to be erasure coded. Okay, so this kind of shows what happens with the old-fashioned write pipelines. You have 3 replicas. Any reads you do, when you're doing a write, the read is visible by any other clients, and you can also force data to become visible by hflush or hsync. Okay, consistency is that client can start reading from any replica and can switch back and forth and will not get confused by where the data is there or not. Okay, so we keep the things, and files can be appended. And so typically what happens is the pipeline goes like this: you write the data and you get back the acts. The other one is for erasure codes. Basically, we do a parallel write, okay, so that the writes go to all the data and come back. Like I said, durability is it can tolerate 3 failures. Visibility is actually the same, and consistency is the same. And also, you can append to the end of a file. Okay. How does recovery work? So, you're writing to the data and it's happening, but let's say one of your data nodes failed. Okay, then what will happen is that it'll continue to write, and the missing box will be reconstructed from the future. If it turns out during the stuff it loses more than 3 of because it can only tolerate up to 3. So if it loses more than 3, it'll actually fail your write and saying I cannot reconstruct, and you have to start again. Okay. In contrast, for example, if you want to look at the old Hdfs, if you have a writer fail in the middle, it'll actually go around it, and you can say what are the number of minimum writers you want. So you could go down to as little as 1 data node or 2, or you can say I'm forced to have 3. Okay, so that's kind of what happens on the old system, just as a contrast. Okay, and when you're reading, again, your read is parallel. Okay, and you read from 6 data nodes. If you happen to have a failure on one of them, okay, then the block is reconstructed by the client side. Okay, so the thing to walk away is the parity calculation during writes is done by the client side. The parity calculations, or the reconstruction, is done by the client side. Okay, there's no central node doing this. So you do need a lot more network bandwidth, because remember, you are reading and writing in parallel. Okay, and you will have a higher reconstruction cost. Okay, so when you reconstruct, you go to read from, let's say, 6 different locations to reconstruct a thing. So your network I/O bandwidth used up to reconstruct in case of failure is going to be higher. So if you have a dead data node, that means you're going to use a lot of high network traffic, and there's going to be reconstruction time. Okay, so the table kind of shows how many local reads and network reads happen in case of the 2 approaches. Okay, the thing to kind of note is that I'm not trying to imply here do not use it. So yes, you can use it, you better have a good network. Second thing is that because of the high reconstruction cost, we are really telling people use it really only for your archival data. At this stage, that's the only thing we are recommending. We're saying your active hot data, you put it in regular Hdfs files, and for your archival, put it there. Therefore, you get all the best characteristics of getting the replica, the multiple parallel I/O things. And for your archival data, which you're only going to read occasionally in your queries, put it on the Reed Solomon if you need. Okay, if the cost is not a big issue, I personally would stick with using replication over Reed Solomon. Okay, but it is a feature that's been demanded by a lot of customers, and it's finally out there. Okay. So now I'm going to switch to Yarn. A lot of stuff there. The scheduler enhancement support for long-running services, which is really exciting. There's a re-architecture of the Yarn timeline service, better elasticity, resource utilization, resource isolation, and in particular Docker, which is also very exciting. There's a better user experience UI and a whole bunch of other minor enhancements. Okay, so scheduling, we've added notion of priorities within a queue. Typically used to be first in, first out within a queue. So Yarn has queues. And now in a queue, you can say, I want priorities for particular apps, okay, within that queue. Second thing is that now you can have inter-queue priorities. So typically what used to happen with Yarn is that when it's scheduling, it looks at the unconsumed capacity of a queue and gives priority to a queue that has higher capacity. So for example, let's say you had a queue with 70% capacity and another queue with 30% capacity. As new things become available, it says, oh, the 70% capacity queue, has got so much capacity, it needs to be consumed, so it gives it there. But you know what? You might have done that way not because those are higher priority queues. You really may want to say, I have production jobs that only need to use 30%, but I want to give them the priority. And so this fixes that problem. Okay, there is affinity and anti-affinity, which can have restrictions on locations of where things are located. And a major one, a very important change is we got rid of scheduling used to be triggered on node heartbeats, okay? And it was really not a global scheduler. So what we have now done is we've replaced that with a global scheduler that has a bunch of parallel threads. Okay, so now 3 things that are really important for that. One is that you can now have global optimal placement. Okay, and this is means that the system can look at the queue, can look at things inside the queue priorities, and can start now scheduling on that. It could even start it down the road, start scheduling on when you want a job to complete. We don't have that feature in, but this new design will let us evolve the system to that model. Also, it is more critical for longer running service because they stick to the allocation. They run for long. And I'm going to tell you about long running services in a few minutes. So your choice of where you run must be a good one. And therefore, a global scheduler could take that into account. And because of the parallelism now, the enhanced scheduling can actually turns out if you do the measurements, it can schedule at 6x the speed of the old one. The old one actually was pretty fast, but now this one is even much, much faster. Okay. So now I want to talk about long-running services. This is a really, really significant feature that we added. It was actually part of the original Yarn design. So Yarn design wasn't originally designed just to run batch jobs, but we started off with batch jobs because that's what Hadoop used to be. We did that, but the original architecture was designed that we could at some point do long-running services. Okay. And so that is something. Why do people want to run long-running services? Okay, there are several reasons. You may want to do a consolidation of your infrastructure. A Hadoop cluster has a lot of compute, a lot of storage, and some of the resources may be unused. So you might say, can't I use my Hadoop resources to run my non-Hadoop load? Because getting hardware from your IT department might take you 6 months. And capacity, but you cannot run, let's say you want to run a web service, Apache web service, or some other service. I like to just run it on this infrastructure. Things like OpenStack are typically quite hard to run. Can't I use yarn instead? Or VMs are actually very, very expensive because the overhead on a VM is very high. Can't I use yarn and containers and Docker? Okay? And of course the question is, does it support Docker? In which case it would be even better because you have a lot of Docker services. We heard you, and you'll see that's what's coming. Okay? Now, the other thing is that often outside of a Hadoop cluster, you may run data services for ingestion and things like that, Flume, NiFi, etc. And you might say, you know what, why can't I run them on the Hadoop cluster itself? Okay? They are long running, and Hadoop didn't support that very well in the past. Okay? So that's another example. And then you have things like Hadoop services themselves, Hive, HBase. Typically, they get run on the bare hardware by Ambari or Cloudera Manager. And the question is, why can't I just run them on Yarn, which would automatically allow you to run multiple instances and would actually benefit from Yarn's elasticity and resource management features. Okay, so those are the key driving features for that. So what we have done is there used to be a project called Slider, which was kind of an add-on module, and so we've kind of moved that into Yarn proper. Okay, we've created a common framework for running long-running services. We've simplified the APIs to manage our service lifecycle, and the Yarn itself, as you will see, as I mentioned a few things, has features to support long-running services. Okay, so for example, policies of preemption, container reservations have been changed to support for long-running services, auto restart of containers. So you can say, I want a container or a service to be restarted, and containers of long-running services are retried first on the same original node, so that if you have state, it can use it. Okay, local state. Sorry. On the disk. The other stuff is that, there's work on supporting upgrade or rolling upgrade of a service, because we really expect services to cross the version of Yarn and the version of the Hadoop cluster. Okay, and there is a certain amount of dynamic container configuration that has been added, so you can just ask for the resources you need and adjust them high or lower later on. Of course, memory doesn't quite work that way, that easily. Memory is a lot trickier to do. There's some games that can be played, but as an overview talk is too hard for me. I don't have enough time to go into the details. So there's some tricks that can be played, and the Yarn community will actually discuss that. In fact, LLAP, which is a long service that does use a lot of memory, is memory intensive, is going to be playing some of these tricks. Okay. So services can run on any Yarn node. So how do you get its IP address? How do you connect to it? Okay, and furthermore, it can move if there is a node failure, which is really one of the benefits of running it on Yarn instead of running it on a node. So we built a Zookeeper-based name service that is used to register, and of course, it can also be used to discover. But a common way to discover really is DNS. So we expose existing information in the Zookeeper registry, which we kind of call the Yarn registry, but really it's not a Yarn registry. We're just using a sub-part of the Zookeeper namespace for this via the DNS registry. Via DNS, excuse me. And current Yarn's service registry records will be converted into kind of DNS compatible. There's a current implementation, and there's going to be an enhancement of that implementation. Okay, so you can, for example, look up the container IP or its service port via standard DNS lookup. You can register both the IP address, the service name to an IP address, and also the port. So you can look up for an application or for a container that you create. Okay. Moving on, much more elastic resource model. We allow you to tune up and down node manager's resource at runtime. Okay, and this is all more towards getting towards more of a cloud, whether using Yarn itself or running to behave like an internal private cloud. Okay, or maybe down the road, or if you are using Hadoop in the cloud itself, and you may want to take advantage of some of these things. The other one is graceful decommission of node managers. So you may want to remove a node manager, By that I mean remove a node from your compute cluster. And when you do that, you want to do a graceful shutdown. So you want to kind of drain the node as it's being decommissioned to allow running containers to finish, okay? And this again, is useful if you're going to decommission a node for let's say repair or something. But it's in fact even more important in a cloud environment where you're going to say, I've been using spot pricing and I needed something, I expanded my cluster. Now, you know what, my load is, my capacity is more than I need. I'm not going to shrink and give some nodes back to the cloud, in which case you want to start draining them. So it's kind of for the private cloud and also for the public cloud, okay? And it allows also one to do container resizing. Okay, again, very much useful for long-running services in general, not typically for batch kind of jobs. Okay, there is improved resource isolation, so we do isolations on both disk and network I/O using Linux container. Okay, so you can get a fair share of disk and network resources using C groups. Okay, the natural thing to do is to start supporting launching of Docker containers, and so it gives you the packaging and the resource isolation beyond what containers give you, okay? Because containers don't give you any kind of how to package your application. And this really complements Yarn's long-running services that I explained a little bit earlier, okay? So with that, you can run Docker on Yarn. In fact, you can even run Yarn on Yarn. Okay, so here what I've shown you is a Yarn cluster. I haven't shown the boxes below it. And I'm running a bunch of Hadoop apps, S processes, MapReduce, Stairs, Spark, whatever. Okay, you've been running that. And you may say, you know what? I want to run TensorFlow. It's available as a Docker application. Bang, I can just run it on Hadoop directly. And so you can start using it to run services and things that are packaged as Docker, okay? You don't have to use Docker. You could also use just containers plain if you're willing to load the binaries yourself. Indeed, we could have gone and just also supported VMs, and so help you even launch a VM if you wanted to. Yarn is not tied to processes as the container it loads, okay? But what you can do is in a bunch of Docker containers, you could run Yarn itself, and then run, in a sense, a mini cluster on top of Yarn. In fact, this is what we do at Hortonworks when we test Hadoop. So all our QA testing in Hortonworks, which used to run some on the cloud and some on OpenStack, a lot of it is now moving to running on a Yarn cluster, which we call the Y Cloud, okay? Yarn Cloud, and we run, hundreds, tens to 100 Hadoop clusters on top of a 150, 200 node cluster. You get much more efficiency by the fact that you are using containers instead of VMs, a lot cheaper than running on AWS or any of the clouds. Okay, so our bill from some of the cloud vendors has gone down, and much more reliable and robust than OpenStack, which is what we used to run before, okay, and simpler to run. So we are kind of internally using our own dog food for testing Hadoop, and so this is something that's really, really exciting. So if you're somebody who's got a cluster and you want to create a little test cluster on top of it, you could potentially do it. So really, it opens up a whole bunch of doors for using your Yarn cluster or Hadoop cluster in ways that was not possible before. I think this is a really significant improvement. Okay, there is a completely new UI. Hopefully, this is not too small for you to see. The top left-hand picture, for example, it shows you, a particular app that is running and how much it is consuming on each of the clusters. So what is being consumed on a particular cluster in terms of apps running or free. And you can also look at a particular app and say, where is it running, which is the picture slightly below. If you look at the two top left-hand pictures, you can also get a very node-centric view on what is running on each of the nodes, and app-centric view. You can get kind of a usage of memory in say, as a heat map. So significantly, we have improved this. In fact, this is kind of how we are using to manage our own Y Cloud cluster. It's kind of very detailed, hard to read this, but it is pretty much improved over the previous thing. okay? The other one is there's an ATS, which is the timeline service that has been upgraded. There were a number of limitations in the first one. There were scalability issues, usability issues, reliability issues, and the model was not as flexible. Okay, and so that is something that we wanted to change for a long time, and it has been improved significantly. There's a lot of detail for me to go into. So, for example, there's a distributed write path. There's a pluggable backend storage. There's an enhanced data model. Separate reader instances, aggregation, accumulation. In particular, we are moving towards using HBase as the backend for this. Okay. And so let me kind of move towards other things that are planned in the yarn space. More resource profiles, so you can specify resource profile instead of individual resources. So resource types can be configured via config files. Federation for yarn itself to allow yarn to scale to tens of thousands of nodes instead of just 5,000 to 10,000 nodes. And so clusters may appear as a single cluster to the end user. There is gang scheduling that is potentially coming up. I actually had intended to put a slide for Hdfs, what is coming down the road. I forgot to actually do that. So let me, since I've got a little bit of time, let me just mention some of the parts on Hdfs. There's actually a talk by Nicholas, I think tomorrow afternoon, I believe, on some of the features that are adding in Hdfs. So Hdfs is one of the limitations, one of the strengths, and also ironically the weakness of Hdfs is the fact that it keeps all its namespace in memory. And it did that originally not because we were stupid or not because Google was stupid, because it did the same thing and we adopted the design. But because if you had to have a namespace that supported 60 to 100K clients running on a 5,000 node cluster, they're going to be bombarding parallel IO, file system request to a single file system. How do you do that? Because you were to send this to even the very high-end NetApp filer or a database, you would just kill it. So either you needed to go to a very parallel system, and so what they decided at Google, which is an idea we adopted, was to keep the namespace in memory. And, so that actually worked very well in the sense that the name node has very low latency and can support, thousands, tens of thousands of clients concurrently bombarding it. The limitation of that, of course, is that you cannot scale beyond what your memory can hold, and because, Hadoop is built using Java, you kind of are limited by how much can a GC collector manage. And so right now, it's in the order of 128 to 150 gigs of memory is typically where a GC algorithm works very well. And so you're kind of limited to somewhere between 250 and 300 million files, okay? And as part of that work, we in 2011 added something called federation, so you could have multiple name nodes. And that, by the way, is in use at Twitter, Yahoo, and also Facebook has backported it to their version of Hdfs. So what we are changing in a very fundamental way is two things: the namespace management and the block management. And so now the plan is there's actually Jiras out there where we'll be storing blocks, not as blocks, but as blocks inside containers. So instead of block reports, you'll have container reports. And a container of storage is typically going to be 2 gigs to 16 gigs or so. And that size is kind of tied to what your network bandwidth and your cluster size is, so it keeps your recovery very fast. And so that'll let you immediately let you scale to a lot more blocks, and therefore you could have smaller files. So one thing I forgot to mention, the original hypothesis at Google and also at Yahoo was that people would create large files, and turned out that was a false assumption. It's very hard to get application writers to create large files. Yahoo, for example, was able to force their application writers to do it, Facebook also, but as we made Hadoop available to a lot of enterprises, they have a hard time doing that. So it'll let you create a lot of small blocks, okay? And then the other part is partial namespace. Something we have prototyped is not to store the entire namespace in memory, but just a working set. And that doesn't mean you're suddenly going to have a name node running in 5 gigs or 6 gigs or 8 gigs. Because remember, in Hadoop, you have a very large cluster. So you want your working set to be in memory. You don't want to get it from the disk. So we are still talking about you getting, a 64 gig name node, but only the working set. And why does that idea work? Because remember, you might have in Hadoop 5 years of data, but your hot data is only the last 3 months, 9 months, etc. So you can store a large working set. Occasionally, you will be going and accessing data in, say 5 years ago, to run a query, and so that part will be paged in. If you repeatedly run that query, it'll again be in the working set. So that's kind of the model where Hdfs is going. That's not part of Hadoop 3.0, but it'll be probably in 3. something or 4.0. That work has already been prototyped in the middle of building it, and being prototyped, and now the stuff will be put back into Apache. Everything we do always goes out in Apache. So that kind of covers the Hadoop 3 content. So that's kind of the end. There is a birds of feather, several of them, on various parts of the Hadoop ecosystem. So I encourage you to go there on Thursday after 5 o'clock. Of course, there are a lot of related Hadoop talks in the rest of the conference, so please, and you have the schedule for that. But since many of you are here for the community, they are kind of community. The birds of feather is really a discussion among the developers in the community and the users. So you will find interesting discussions. You go there as a developer who's contributing to Apache, or as a user of Hadoop technology, to talk about what you believe the community should be working on. So please, if you have a chance and are interested, please go there. So I'm going to now pose for questions. Good point. Okay, so I actually had a slide. I took it out on that because I thought I was going to run out of time. And I probably was talking faster than I should have. So no, there is a notion called something group. I forget what it was, okay? And so what happened is there's a grouping of block groups, so that inside the namespace, I don't have to store 9 addresses in just one. So there's computer science, everything is done by one level of indirection. So we did that. So there really shouldn't be too much of an impact on the namespace from what I know. Okay, so we did address that.
Yeah, maybe I misunderstood it. I've seen that for creating arrays, you put zone. So create a zone, and each file you put in the zone is arrays coded. Why is not this property is not set for each file, like replication factor?
This was, I think it's a subjective thing. So what has happened is things like encryption zone. There's something called encryption zone. And so what people wanted was, I have things that, if you kind of manage it on a per thing basis, then applications would have to be responsible for setting that property. And typically what people want is the admin will say, you know what, data here, even if it's hot data, I want it to be encrypted because I know the data is very big or something. So he just creates a directory, and the applications, he in the directory goes and sets that property and banks something, everything starts to be encrypted. That's one example. Second one is I want to now have an archival stuff, in which case I could go and take my existing directory and set that zone and it'll archive it, and future stuff that's moved in the archival will automatically archive. So I think it was more from an administrative convenience, because we don't expect applications to know what they should be using, okay? Because it has an impact not on the correctness, but it has an impact on the performance and other cost. That was the reason why that was done. Other questions? Yes, please.
Speaking of the long-living yarn containers, what other Hadoop services
So for Hive, actually, from a Hive feature point of view, it doesn't really make a difference, okay? Yeah, so let me tell you where it does make a difference. Because in Hive, you know, the LLAP containers are long running, okay? We could have done Hive, for example, in the Hortonworks distro, we could have implemented Ambari installing the LLAP. Instead, we just made it convenient to use this service to do it, okay? But there is another advantage. Let's say I want to run multiple versions of Hive, okay? And let's say, you know, for example, Ambari doesn't support it except till in the next release it will. And you could support it by just running it on Yarn. So if you want to run multiple instances of Hive or Uzi, etc., and potentially different versions, because in your organization you have some people wanting Hive 2, some people wanting Hive 2.3, and so you could run much. So really, yes, it will be supported, and we'll have to make sure that the packaging and the service works that way. But yes, the plan is to move towards that. So things like key tabs and things like that we traditionally. If you have a long-running service on a secure cluster, after about a week, the delegation tokens expire? Yeah, so yes, there is work over. Sorry, we are out of time. So let me just finish this question. So yes, there is work on renewing the delegation token. Okay, further, and non-Hadoop services don't depend on the delegation token. So for things like other Docker stuff, you could just run it. But for Hadoop services, yes, you're right. So there is work going on there. Okay, thank you.